Hiya, Mr. Green here. I'm going to be taking you through this lesson, which is part of the particle theory section of the physics content. This is a lesson on specific latent heat, and your learning objective is to learn what happens when substances change state. If you could pause the video and put that down as your title, please. Okay. So we start with some retrieval questions. If you could pause the video and answer these 5 questions, unpause it when you'd like the answers. Okay, question 1. What's the definition of pressure? Pressure is defined as force divided by area. So the amount of force exerted on something divided by the area over which that force is spread. So a high pressure would be over a very, very small area, a low pressure over a massive area. How can we increase gas pressure? Well, if you remember, gas pressure is caused by gas particles bouncing off the insides of a container. How can we make them bounce off the insides of the container more? We could increase the temperature. That makes the particles move faster. We can decrease the volume, meaning they're going to hit the sides more often. Or we can increase the particles of gas present. Making more particles makes more collisions take place. How did Robert Brown observe random motion? We call this Brownian motion now after his experiment, and what he did was he suspended pollen grains in water and he watched them through a microscope, and he noted that the pollen grains constantly moved in a random direction. This proved they bounced off water particles, showing that things were made of particles. Question 4. What's condensation? Condensation is when a gas turns into a liquid. And question 5. What is desublimation? Desublimation is when a gas turns straight into a solid. It misses out the liquid part and goes straight into a solid. Okay, our learning outcomes today is to state and explain what is meant by the specific latent heat of a material, and compare and contrast latent heat of fusion and latent heat of vaporization. Okay, so for our starter, we have there a graph. The graph is temperature against time, and it's showing a solid being heated. As the solid's heated, its temperature rises. But as soon as it starts to melt, the temperature remains constant all the way through its melting. Here's your question. If the energy being provided to the substance between these 2 points isn't increasing the temperature, what is it doing? Pause the video whilst you answer that question. Okay, what it's doing is, as it's going from a solid to a liquid, those particles are overcoming forces of attraction or breaking bonds. Rather than going into increasing the temperature, that energy is going into overcoming those forces of attraction, to breaking those bonds, and as it's doing that, it changes the state. Very quickly, internal energy. There is a screencast on this, but just briefly, what is internal energy? Well, internal energy is the kinetic energy that particles have due to the motion of individual particles, and the potential energy the particles have due to their position. The internal energy is therefore defined as the combined energy of the kinetic and potential energy of the particles in a substance or a system. Pause the video while you get that definition down. Okay, so changing state. What happens to the position of the particles if a substance changes? So if it changes state, the potential energy of the particles increase. So therefore the overall internal energy increases. When it's a solid, the particles are held in one particular place. As you move it to a liquid, the potential energy increases. The position where they are moves around. And then with a gas, even further. So as we go from solid to liquid to gas, the potential energy of those particles increases. We can cause substances to change by increasing their internal energy or lowering their internal energy. So we're trying to make the internal energy higher if we are pushing those particles apart. Now, in order to change state by changing the position of the particles in a substance, there's got to be a change of energy in relation to the forces between the particles. For a solid to go to a liquid, those forces can't be as strong anymore. Those forces must be weaker, otherwise they wouldn't be able to move. Now, the energy to cause a change in state of a substance is referred to as the latent heat. So the amount of energy we need to place in to break those bonds and to weaken those bonds so the particles can then move, we call that the latent heat. Again, pause the video whilst you get that definition down. Okay, so we've stated that the energy transferred to a substance when it changes state is called latent heat, and this happens at two different points. It changes state from a solid to a liquid, or from a liquid to a gas, and you've got the other way around as well, from a liquid to a solid and from a gas to a liquid. So whenever states are changing, latent heat is being applied. You can see on the graph there, solid to a liquid and liquid to a solid and liquid to a gas and gas to a liquid. Now the specific latent heat of fusion can be defined as the energy supplied to change 1 kilogram of a substance from its solid state to its liquid state. So how much energy does it take? How much energy to melt ice? If we want ice to change from a solid to a liquid, how much energy would we have to put in to change a kilogram of that ice into liquid? Here's how we work it out. The latent heat of fusion is equal to the energy required divided by the mass taken. So, specific latent heat of fusion is measured in joules per kilogram, energy in joules, mass in kilograms. So using that equation, grab your calculators and calculate this first thing. Calculate the specific latent heat of fusion for water or ice if 2 kilograms of ice requires 666 kilojoules of energy to melt. Pause the video whilst you attempt that. Okay, so latent fusion heat, 666 kilojoules, we have to transfer that into joules. So that's 666,000 joules. We divide that by the mass, which is 2 kilograms, giving us a value of 333,000 joules per kilogram. That can also be expressed as 333 kilojoules per kilogram. So if we have a kilogram of ice, we have to divide it with 333 kilojoules in order to melt it into a liquid. Latent heat of vaporization is slightly different. If latent heat of fusion is the change of state from a solid to a liquid, latent heat of vaporization is the change of state from a liquid to a gas. So there's our definition. Specific latent heat of vaporization refers to the energy supplied to change 1 kilogram of a substance from its liquid state to its gaseous state. So how much energy would it take for water? Again, latent heat of vaporization is exactly the same equation. The energy required divided by the mass of the object. Units are exactly the same. So here's our second question. The specific latent heat of vaporization for water. If 2 kilograms of water require 4,520 kilojoules of energy to turn into steam. Pause the video whilst you attempt that. Okay, so again we need to convert. We've got 4,520 kilojoules, we convert that into joules. So our equation is 4,520,000 joules divided by 2. 2 is the kilograms. That gives us 2,260,000 joules per kilogram. We can convert that to 2,260 kilojoules per kilogram. Okay, 5 questions for us here. If we could pause the video and attempt to answer those questions. Remember to use your calculator, and you can spin back on the video to make sure you've got those equations as well. Look at those examples again. So pause the video whilst you attempt those. Unpause it when you'd like the answers. Okay, so question 1. Why does the temperature of a substance not change while the substance is changing state? This is because the energy being supplied to that substance while changing state goes into breaking the bonds between molecules, not into raising the temperature. What's meant by specific latent heat? Specific latent heat is the energy required to change 1 kilogram of a substance to different states. Again, it's really important that you know it's per mass, so it's a 1 kilogram of a substance. Okay, question 3. The latent heat of fusion for aluminium is 3.97 times 10 to the 5 joules per kilogram. How much energy will be required to melt 0.75 kilograms of it? Well, we need to rearrange our equation. Initially, we know that latent heat of fusion is energy divided by mass. So if we rearrange that, energy is equal to the latent heat of fusion times the mass. 3.97 times 10 to the 5 multiplied by 0.75 gives us 297,750 joules. Question 4. If we're given 500 grams of gold, how much energy would be required to melt it? The latent heat of fusion of gold is 64.4 kilojoules per kilogram. So again, first thing we need to do is convert our mass. We've got 500 grams, that becomes 0.5 kilograms. To work out the energy, it's 64.4 times 10 to the 3, the latent heat of fusion, multiplied by the mass, which is 0.5, gives us 32,200 joules, or 32.2 kilojoules. And finally, what is the latent heat of vaporization of oxygen if 428 kilojoules of energy is required to vaporize 2 kilograms of oxygen? Well, latent heat of vaporization is energy divided by mass. That would be 428 divided by 2, 214,000 joules per kilogram, or 214 kilojoules per kilogram. Please pause the video and ensure you've got all those answers noted down correctly. Okay, 2 more questions here for you to attempt. Make sure you've got your calculators with you. Pause the video whilst you attempt them and unpause it once you want those answers. Okay, question 6. Water's got a density of 1,000 kilograms per meter cubed. A volume of 0.005 meters cubed of water is heated. How much energy is required to turn that completely into steam? The latent heat of vaporization of water is 2.26 times 10 to the 6 joules per kilogram. Okay, so if we know the density of water and the volume of the water, we can work out the mass. Remember, density is mass divided by volume, so rearranging that, density times volume would give us mass. That gives us 5 kilograms of water. We multiply that by the latent heat of vaporization, which is 2.26 times 10 to the 6, giving us 11,300,000 joules, or 11.3 megajoules. Question 7. A beaker of a substance has an initial mass of 0.25 kilograms, which then reduces to 0.232 once boiled. Calculate the latent heat of vaporization of the substance if 15.3 kilojoules of energy is provided to it whilst boiling. Well, how much has actually evaporated? How much has vaporized? That's 0.25. Take away 0.232, so only 0.018 has vaporized. We divide the energy needed by the mass, 15,300, by 0.018, giving us 850,000 joules per kilogram, 850 kilojoules per kilogram. Okay, to finish off some multiple choice questions, please pause the video whilst you answer those. Okay, question 1. Internal energy is, so is it A, B or C? Correct answer in this case is B. Internal energy is the combined energy of the kinetic and potential energy of the particles in a substance. Question 2. Latent heat of vaporization. Is it A, B or C? Correct answer in this case is C. The energy required to change 1 kilogram of a substance from liquid to a gas. Could be from a gas to a liquid as well, but vaporization is that state change, gas to liquid. Question 3. Latent heat of fusion is that A, B or C? Correct answer in this case is B. The energy required to change 1 kilogram of substance from a solid to a liquid. Again, it could be from a liquid to a solid, but fusion is that state change, solid and liquid. Okay, I hope that was useful. If you want to know any more, please just review that and attempt all the questions again. Hope it was useful. See you again soon.